Hello friends, myself Rajendra Mahajan presenting my video on Euler's theorem for homogeneous function. Let us solve the problem. If t is equal to sine of xy divided by x square plus y square plus root of x square plus y square, then find the value of x dou t by dou x plus y into dou t by dou y. We have to identify the type of the problem. Here given is t is equal to sine of xy divided by x square plus y square plus root of x square plus y square. First term we call as u and second term we call as v. Therefore, t becomes a sum of two functions u and v. We call this as equation 1, where u is sine of xy divided by x square plus y square and v is square root of x square plus y square. Both are homogeneous function in x and y. U is homogeneous function in x and y. Transferring that sine term to left hand side, we get sine inverse of u as xy divided by x square plus y square. The sine inverse of u we call as f of u, function of u as sine inverse of u, and differentiating it with respect to u, we get f dash of u as 1 upon square root of 1 minus u square. F dash of u as 1 upon square root of 1 minus u square. This is and second part. We require to find the degree of homogeneity. If we see the term in numerator, the degree of that term is 2 and degree of denominator term is also 2, and therefore here the degree of homogeneity is 2 minus 2 as 0. And then by Euler's theorem we get x into dou u by dou x plus y into dou u by dou y, as it is function of function, we use this formula. It is equals to n f of u by f dash of u. By Euler's theorem we get x dou u by dou x plus y dou u by dou y is equal to n f of u by f dash of u. Substituting the value, we get n as 0, and therefore this term becomes 0 as n is 0. We call this equation number 2. The second function is v. It is the root of x square plus y square. It is nothing but taking x square common from this. Square root of x square is x, square root of 1 plus y square by x square, nothing but y by x whole square. And therefore v is homogeneous function in x and y with degree n is equal to power of that x. Here n is 1. And then by Euler's theorem we get x into dou v by dou x plus y into dou v by dou y is equal to n into v. The value of n is 1, therefore 1 into v we get as v, and we call this equation number 3. Therefore, once again I will repeat the steps. First step, we are writing t as sum of the two functions u and v, where u is sine of xy divided by x square plus y square, a function of homogeneous expression. Then transferring this sign to left side, we get sine inverse of u as xy upon x square plus y square. Differentiating it, we get f dash of u as 1 upon square root of 1 minus u square, and degree of numerator term is 2, degree of denominator term is also 2, and therefore the degree of that function is 2 minus 2. We get n as 0. And then applying Euler's theorem, for u we get x dou u by dou x plus y dou u by dou y is equal to n f of u by f dash of u. Value of n is 0, and therefore this term becomes 0, and we call this equation 2. Similarly, we perform for v also. Taking x square from common from this 2 term, square root of x square is x, we get square root of 1 plus y by x whole square. It is a homogeneous function in x and y with degree. Whatever the power of x, that is the degree of that function, and therefore we get n as 1. And then by Euler's theorem, we apply Euler's theorem for v also. We get x dou v by dou x plus y dou v by dou y is equal to n into v, as it is function of xy only. The previous, it is function of function. Therefore, we are using some different formula. We get that value as v, equation number 3. And then adding equation 2 and 3. We take the addition of left hand side term and addition of right hand side term. Therefore, it is x dou u by dou x plus y dou u by dou y plus x dou v by dou x plus y dou v by dou y, sum of left hand side term, and that is equal to sum of the right hand side term, 0 plus v. And therefore, there are two terms of x dou by dou x. Here it is operated on u, and here it is operated on v. Therefore, I can take x dou by dou x common. Remaining terms are, here it is u and here it is v. Therefore, it is u plus v plus there are two terms of y dou by dou y. Again taking common, operated first on u and then on v. Therefore, remaining terms are u plus v, and that is equals to v. What is v? Root of x square plus y square. And therefore, we get the required value x. U plus v is nothing but capital T. Therefore, it is dou t by dou x plus y. Again, u plus v. Therefore, it is dou t by dou y is equal to root of x square plus y square. That is the value. It is the root of x square plus y square as a required answer or required value, obtained by applying Euler's theorem separately for u and separately for v, and then adding that two results to get this value of x dou t by dou x plus y dou t by dou y as square root of x square plus y square. Please like my video, share it, as well as subscribe to my channel, and to receive the notification of such type of new videos, please press the bell icon. Thank you. Thanks for watching.